My name is Gerardo Gutierrez. This is my digital design presentation, and today we will be designing a bidirectional 4-bit shift register using JK flip-flops. It will take a logic input known as direct over here, and depending on the value of direct, if direct is 1, our register will shift right. If direct is 0, our register will shift left. The way we can implement this is by taking a pair of AND gates and introducing them at each stage of our circuit. The reason for doing this is that essentially we want 2 routes for our circuit to be able to take. These 2 routes being rightmost and leftmost shifting. Let's consider the rightmost shifting first. For rightmost shifting, what we're going to want to do is take this R value over here, which for the sake of our design stands for our serial input, right? Which is a series of time-dependent bits that will essentially shift. And so we'll take that and feed it directly into this first AND gate. Now, these left AND gates at each stage will consider our primary AND gates for rightmost shifting. And so if our direct has a value of 1, we can take that value and feed it into all of our primary AND gates, and will therefore activate all of them. And that will be our rightmost shifting route. Now we have to keep in mind that we're using JK flip-flops, and so if our J is 1, we want our K to be 0 for our overall flip-flop state to be 1. The way to do this is quite simple. All that's necessary is an inverter for our J value, and we will input that for our K value at each stage of the design. Now for leftmost shifting, well, before we go into leftmost shifting, I should consider the output bit of each stage. What we want that to feed into is pretty much the active stage of the next flip-flop. The active gate for the next flip-flop. And so that ensures that all of that will flow nicely. Now, for leftmost shifting, what we want is quite the same, but a bit different. So what we want to do is take our serial input left, which is analogous to our serial input right, as our series of time-dependent bits that will be shifted, and input it first secondary AND gate. And the reason for its position all the way over here is because we need to shift in the other direction. So the output bit of this guy will go into the secondary AND gate of every stage. The other input being our inverted direct signal, which will activate all of these secondary gates and allow a leftmost shifting. Last but not least, we will take our clock input and input it to all of our negative edge triggered clock inputs. And there we have our 4-bit bidirectional shift register